Alright, how do we determine if a reaction is a redox reaction? So remember, in a redox reaction we have one atom is going to be releasing electrons and another atom is going to be accepting electrons. So how do I do it? I label every atom on both the reactant and product side of the equation with its oxidation number. And if there is a change in oxidation number from one side of the equation to the other side of the equation for the same type of atom, it's a redox reaction. So each complete equation must have at least one species losing electrons and one gaining electrons. If you only have one thing, if you only have gaining going on, you've made some sort of mistake. The loss and gain of electrons are going to be reflected in changes in oxidation number. Sometimes you'll get an atom that can be oxidized and reduced at the same time. They're not very common. I think later on we'll come across one. So let's do two examples together. Okay. Here it is right here. Is this a redox reaction? So what I need to do is I need to assign oxidation numbers to everything in this equation. Minus 2 for a total of minus 14, plus 1 for a total of plus 2. I got to hit 0 in the end. Looks like I need this to be plus 12. There's 2 of them. That's a 6. Plus 1 and plus 1 and minus 2. Minus 2 and plus 1. Minus 2. K is going to be plus 1. This is a minus 8 over here. There's 2 at plus 1 is plus 2. Looks like the CR has got to be a 6. So now let's take a look at the atoms. On this side, K is plus 1. And on this side, it's plus 1. On this side, O is minus 2. On this side, O is minus 2. On this side, CR is plus 6. On this side, it's plus 6. H is plus 1. H is plus 1. All the oxidation numbers on this side are the same as the ones on this side. This is not a redox reaction. Next one. Same thing. Let's assign some oxidation numbers. If you want to pause the video and try it yourself, that's fine. Otherwise, I'm just going to keep going. Minus 2. NO3 has a charge of minus 1. Just this little polyatomic ion means Ag is going to be plus 1. Looks like N is going to be a 5. Cu is 0 because it's all by itself. NO3 is there. Just for the record, here it is right here, so it's going to be 5 and a minus 2. Looks like Ag is a 0 because it's by itself. Again, NO3 is a minus 1, and I have 2 of them, means I have minus 2 right here. Looks like Cu's got to be plus 2. So when I look here, O is the same, N is the same, but Ag seems to be going from 1 to 0, and Cu seems to be going from 0 to 2. And currently, I am happy. I'm happy because one is going down and the other one is going up. Means that if they both go up or they both go down, I've got a bit of a problem there. I've made a mistake somehow. But I want one going up and one going down. This is a redox reaction. Okay. And for the record, when I look at this, oxidation is an increase in oxidation number, and reduction is a decrease in oxidation number. So that's how I tell if a reaction is a redox reaction or not.